Chapter 12, Part 4. In addition to selecting the appropriate packaging materials, CS technicians must understand how to use sterilization packaging appropriately to achieve the desired results: sterilant penetration, barrier effectiveness, and aseptic opening. Packaging systems used in healthcare facility-based sterilization are generally classified into reusable packaging and disposable single-use packaging materials. Each packaging system has advantages and limitations. The following sections provide some basic information about common packaging systems and their applications. Reusable packaging materials. There are two basic types of reusable packaging material: woven fabric and rigid containers. Woven fabric materials. Before the early 1980s, woven textiles were the reusable packaging material of choice. However, new technologies have increased the choices for sterilization packaging. The standards for manufacturing today's packaging materials have been based on penetration and microbial barrier capability measurements for a minimum of 140 thread count, threads per square inch. Muslin, type 140, thread, cotton, thread, calico, and barrier cloth are common names for fabrics made of 100% unbleached, loosely woven cotton fabrics. Muslin wrappers are generally made of 2-ply, double thickness fabric fastened together as one wrap. See figure 12.29 for an example. Other woven fabrics used in sterilization are duck cloth, twill, treated barrier fabrics. Note: canvas is not recommended as a packaging material because its tight weave impedes steam penetration and drying. Muslin. Broad term describing a wide variety of plain weave cotton or cotton polyester fabrics with approximately 140 threads per square inch. Textile packaging is still the packaging method of choice for some healthcare facilities. The selection of reusable textiles is often impacted by costs and/or environment sustainability concerns, the desire to reduce waste generated by disposable packaging materials. Some facilities contract with off-site companies to pick up used textile wrap and then launder, inspect, and return them to the facility for reuse. Textile packaging requires more labor because it must be laundered and inspected to ensure that there are no tears, punctures, worn spots, or stains from previous use. That inspection is performed using a light table that has a light source built into the tabletop to help spot small holes and punctures. As the wrap is passed over the light table, light shines through the small holes and punctures, making them easier to identify. If holes, puncture, or worn spots are discovered, the linen wrap must be repaired using a heat-sealed patch designed to cover the hole. The size of the fat surface area covered by a heat-sealed patches on reusable fabric should be considered before the fabric is used. See 12.30 for an example. Reusable materials with approved heat-sealed patches can be effectively sterilized. However, the limit, the percentage of exposed area that can be patched, depends on the method of sterilization, positioning in the sterilizer, number of layers of patched fabric, and the type of fabric patch. Some patching materials are not fully steam penetrable, but are surface sterilized only. Although the sterilant entering through unpatched areas may be sufficient to sterilize the pack contents, excessive use of non- or semi-permeable patches may hinder the sterilization process. A facility's infection prevention and control committee should investigate the use of patched wraps to establish an accept or reject standard for the total surface area of patch that is permitted for use within the facility. If stains are discovered, the wrap should be relaundered. If stains cannot be removed, the wrap should be removed from service. Textiles must also be delinted as needed to minimize the risk of lint entering the sterile pack and ultimately the sterile field. See figure 12.31 for an example of delinting. Reusable textiles can be a significant source of lint. If lint enters the patient's incision, it may cause negative effects. When assembling linen packs, their size is limited to 12 inches in height by 12 inches in width by 20 inches in length, and they are not to weigh more than 12 pounds. Maximum density must not exceed 7.2 pounds per cubic foot, because higher densities may reduce sterile access to all contents. Linen wrappers should be securely applied without compressing packed contents. Contents must be packaged with sufficient spacing to enable the sterilant to reach all surfaces. Tight packing will not allow for fibrous swelling expansion. When expansion occurs, the sterilant will not penetrate the material. It is possible to wrap even a small pack too tightly that its density will be too great for adequate sterilant penetration. Muslin type wrappers must always use a sequential type of wrapping process. Note, this topic is discussed later in the chapter. Rigid container systems. Rigid container systems are box-like structures with a sealable and removable lid. They are made of anodized aluminum, stainless steel, plastic, or a combination of these materials. Rigid containers have lids and filters that allow sterilant penetration while providing a microbial barrier. Filters may be disposable, a synthetic spun-bound product, or reusable with ceramic filters or a valve system. Rigid containers consist of an inner basket to hold the instruments and an outer container that acts as a protective barrier. Both the inner basket and the outer container have handles for ease of carrying. See Figure 12.32, which identifies the common components of a rigid sterilization container system, outer container. Some manufacturers of rigid container systems recommend that times for instrument sterilization, drying, and aeration be extended when using the containers. It is important to consult the specific container manufacturer's instructions for use before using a rigid container system. Rigid containers are regulated by the FDA, and containers are required to have a 510K pre-market submission certifying that they will perform an effective packaging material. Advantages and disadvantages. There are several advantages of rigid sterilization containers. They are: provide an excellent barrier to microorganisms, are easy to use, eliminate torn wrappers, help protect instruments from damage during processing, storage, and transport. Definition: rigid container system. Instrument containers that hold medical devices during sterilization and also protect devices from contamination during storage and transport. There are also potential disadvantages to the use of these systems, including safety concerns like ergonomics. Some large 12 by 23 by 6 empty containers weigh approximately 7 to 9 pounds. This requires CS technicians to use good body mechanics when lifting and moving containers. Note: loaded instrument baskets must be added to the base weight, and employees should be able to comfortably carry a container or instrument set at waist height. Additional cycle time may be required to thoroughly dry the container. Sterilization efficacy is also impacted as a container's weight increase because of excess condensation. Wet packs have been noted and discussed for many years. While it is difficult to generalize about specific causes of wet packs, it is known that the heavier sets and those with greater metal mass are more likely to experience this problem, especially when instruments are not properly dispersed in the container. Definition: wet packs. Package or container with moisture after the sterilization process is complete. Some more negatives or disadvantages to rigid containers are: plastic containers may require longer dry times because they lack metal, which produces heat by conduction to help drying. Additional space may be needed to store those containers that are larger than traditional wrap containers. See Figure 12.33 for an example. Additional labor may be required since the containers must be cleaned between uses. This may also affect washer loads if mechanical washers are used. See 12.34 for an example. Latching mechanisms on containers create potential problems. When latches and welds break, the containers cannot be used. Also, sharp edges can injure employees. Finally, filter retention plates may become dislodged and contaminate the instruments. Note, some manufacturers have addressed this potential problem by modifying or changing the design of the container's filter retention plate. Cleaning and inspection procedures for rigid containers. To clean a rigid sterilization container, first remove its disposable filters or release its filter protector holder. Valve type closures must be cleaned according to the manufacturer's written instructions. Interior baskets must be removed and cleaned. Dividers or pins may need to be removed if they interfere with the cleaning process. Cleaning and rinsing instructions provided by the container manufacturer should be followed. Particular attention should be given to the type of detergent used. For example, some containers cannot be exposed to certain chemicals, such as high alkaline solutions. Inspections should also focus on the top and bottom valve or filter mechanism and the latching mechanism. For example, the filter retention plate should be intact and not bent. The retention plate should seat over the filter and securely lock it in place. The retention post should be secure and not move. If using disposable filters, they should be checked for holes prior to placing in the container. See figure 12.35. Filters should fit the space allotted with no folding, crimping of the edges. Filter material must be approved for the type of sterilization to be used. Also, if using reusable valves, they should be clean and debris-free, with no breaks or chips in the valve mechanism. Valves should fit securely and not move once seated. See figure 12.36 for an example. Also, the lid gasket should be clean and free of cracks and nicks. There should be no ridges on the gasket. Note, ridges are caused by a tight fit between the top and bottom of the container. See figure 12.37. Also, rivets in the handle area should be checked to ensure that they are secured and not separated from the container. If loosened, they can become a safety hazard and a pathway for entry of bacteria. Finally, handles should be moved up and down easily. Ensure the latch springs are in place. See figure 12.38 for an example. As noted earlier, the weight of instruments placed in the container is an important concern. The number of instruments placed in the tray must not exceed the quantity that can be effectively sterilized and dried. Rigid containers should be carried by both of their handles, not by the lid, to avoid breaking the container's seal or damage the instruments inside. Disposable packaging materials. Disposable non-woven materials were introduced as engineered fabrics in the 1940s and have made their way into everyday life. Coffee filters, tea bags, vacuum cleaner bags, and disposable diapers are all examples of engineered fabrics, also referred to as disposable non-woven materials. These materials are used in both disposable flat wraps and rigid container filters. See figure 12.39 for an example. Before using both disposable flat wraps and rigid container filters, they should be inspected for tears or holes that may have occurred during the transport and handling. These materials are a popular choice for sterilization packaging because they have an excellent barrier effectiveness and can be discarded after use. There are three types of disposable packaging materials in common use: paper, polyethylene plastic, and disposable non-woven wraps. Important note, be aware of packaging expiration dates. Some disposable packaging materials contain expiration dates from the manufacturer. It is important to check for an expiration date prior to using any disposable packaging material, since the expiration date usually indicates a decrease in the packaging's ability to perform at optimal standards, including microbial barrier properties. Papers are commonly used as sterilization packaging materials. It is important to ensure that the paper packaging is intended for use as sterilization packaging and that it has been approved by the FDA. Note: papers containing cellulose cannot be used in hydrogen peroxide or ozone sterilizers because cellulose absorbs the sterilant and reduces penetration. As this occurs, the contents being sterilized may not be exposed to the proper amount of sterilant. Kraft type papers, medical grade, are generally smooth surfaced and they are available in sizes to accommodate many medical devices in porous or soft good items. Pouches of medical grade papers are specifically formulated for sterilization and are also available. Pouches with both sides consisting of craft paper can be used to hold small parts and instruments inside the instrument sets. See figure 12.40. Kraft type papers, also known as cray paper, can also be purchased as flat wraps. These products may be utilized in steam and in ethylene oxide sterilization, but cannot be used with hydrogen peroxide or ozone sterilization. Paper, plastic, and spun-bound polyethylene plastic combinations, called peel packs or peel pouches, are the most commonly used packaging materials for small instruments and lightweight items. See figure 12.41. They are called peel pouches because after they are sealed, they must be opened for aseptic opening and peeled open. There are two basic types of combination peel pouches. Paper plastic combinations. These are typically acceptable for use with steam and ethylene oxide sterilization process. They are not compatible with hydrogen peroxide or ozone sterilization. As suggested by their name, they have a paper side and a plastic side. The plastic side allows for visibility of the package content, and the paper side allows for sterilant penetration. Note: sterilant cannot enter through the plastic side, so proper positioning is important to achieve sterilization. Spun-bound polyethylene plastic combinations, sometimes referred to as Tyvek pouches, and these are used for hydrogen peroxide and ozone sterilization. Like paper plastic combinations, they have a plastic side, so contents are visible. The other side is composed of polyethylene that contains no cellulosic materials and is therefore compatible with hydrogen peroxide and ozone sterilization procedures. Important note: use caution when selecting peel pouches. Paper, plastic, and spun-bound polyethylene packages look alike. Paper, plastic combinations are not compatible with hydrogen peroxide and ozone sterilization, and spun-bound polyethylene thin combinations will melt in high-temperature process, such as steam sterilization. Flat wraps are another commonly used packaging material. Instead of inserting objects into a ready-made pouch and sealing it, flat wraps require the user to create a barrier package using specific folding techniques. See figure 12.42 for an example. One non-woven packaging material, spun-bound, melt-bound, spun-bound, or SMS, is a popular flat wrap. It is made by a process in which polyethylene layers, such as synthetic materials softened by heat and hardened by cooling, are exposed to high heat and are pressure bounded together to form sheets. Flat wrapping products constructed of non-woven SMS fabrics for sterilization wrapping are designed as single-use disposable products and must never be reused. These materials are available in a range of weights and a wide variety of sizes. Flat wraps are also available as single or double sheet wraps that are bounded together. The use of each packaging material has advantages and disadvantages. CS technicians must ensure that they select the type of packaging most suitable for the items being packaged and the type of sterilization selected. CS technicians can then begin preparing the package contents for packaging and the sterilization process to follow. Wrapping techniques. Peel pouching techniques as follows. Peel pouches are usually used for smaller lightweight items. They are also useful when it is important to see the contents of the package, such as when a description of the contents is difficult to view on the label. Peel pouches are available on rolls that allow CS technicians to cut off the length desired for each package, and they are also available in pre-cut sizes. Insert or tip protectors help to protect the pouch's content from damage and prevent the tips from penetrating the package. If inserts or tip protectors are used, ensure that the material is appropriate for the type of sterilization method to be used, and that it's non-toxic and free of non-fast dyes. See figure 12.43. Before placing items in the peel pouch, carefully inspect the pouch to ensure there are no tears or holes. Items should be placed in the pouch so the end of the item can be grasped during presentation. For example, finger rings of the instrument will be presented first when the package is opened at the point of use. Note, this is the chevron end for the pre-made pouches. Note, this is the chevron end as seen in 12.44. See 12.44 for an example, which illustrates the chevron end of a pre-made pouch. It is designed in a manner that makes it easier to open. This reduces the risk of product contamination during aseptic opening. Instrument tips should always face the plastic side of the package to avoid penetrating the paper side and contaminating the contents. Hinged instruments must be packaged in a manner to keep the instruments open for sterilization. This can be accomplished by using commercially purchased products. Pouches must be sized and applied properly to allow for adequate air removal, sterilant penetration, and drying. To allow space for package contraction and proper circulation, leave about 1/4 inch per side on the package. Leave about 1 inch of space between the items in the pouch and the sealed edges. When packaging is too small, then the package instruments can cause stress on both sides of the pouch. See figure 12.45 for an example. Stress compromises the package's barriers and will likely rupture the side seams of the package during harsh air removal and heat up phases of the steam sterilization process, or the high vacuum phase of a hydrogen peroxide sterilization process. Items placed in packages that are too small can also rupture the seams during normal handling and transportation. Pouches should not be too large because movement of the items inside the pouch may result in the contents sliding from end to end or side to side. The excessive movement of the contents should break seals or puncture the pouch's paper. See figure 12.46. Pouches should not be overfilled because they can cause the paper to tear or the seals to rupture during sterilization or handling. See figure 12.47. End of chapter 12, part 4.